Hi, I'm Richard McFarlane, and this is just a short video to go over some of our lab setup. So this is particularly the labs involving the Vyatta router firewall. So this is our setup. So we've got our cloud, and each student gets a group of VMs. So we've got our Ubuntu host server VM, which is going to be on one network. In this case, they're all on the VLAN, the 205 VLAN, all these networks. So you're going to get an X network to set up here. And then you've got a firewall, and you have a Windows server, which is the server host, which is going to sit on the DMZ network. So both these networks are attached to the firewall via these two interfaces here, and these are supposed to represent a kind of safe or trusted inside network, slightly less trusted DMZ network where we might put some of our forward-facing servers, and our router firewall itself. And we've also got an outside interface here, which is connected to a lab firewall, which all the student groups are connected to, and then that's connected out to the Napier network. So you can see here, and this can be accessed from home or wherever you like, via your laptops or whatever, via the internet, as well as being accessed, as we do in the labs, through our kind of wired machines within Napier. So as we go forward, we'll use different firewalls and maybe some other virtual machines. As a Kali machine we can add to the inside networks, or a Kali machine for adding to our external network, depending on whether we want to test our firewalls from outside or whether we want to do some insider type attacks and testing and traffic analysis. So our labs themselves, we're aiming to kind of develop your practical skills, so the applied stuff from the theory, skills towards mainly our coursework, but as well as kind of future modules and things we can build on. So it's very advantageous if you document what you're doing in the labs and what you do at home with the labs. So keeping some sort of logbook, whether that be electronic, whether that be annotated versions of the PDFs, or whether you want to print things out or write on them, completely up to yourselves, but some kind of logbook, so you can hopefully quickly be able to set up these things, debug any configuration, and troubleshoot any problems and test the configurations to make sure they're working. So you can layer basic networking, routing, firewalling, testing. We'll then go on to IDS and more complicated firewalling and things like that. But the idea is you'll be able to quickly set these things up. So I think we've been over that. So that's just remotely accessing the vSOC. Yeah, and as I said previously, so using tools, we want to actually learn what the tools are doing, not just run the tool in some way where we kind of hope that it does something useful. So we want to be checking the man pages, we want to be looking at the help with -H for command line tools. If you're not sure what a security tool does, maybe don't use it until you understand it, because some of these tools can generate large amounts of traffic, or they can attack target machines by accident, or just misconfiguring some of the network stuff in these virtualized environments can mean other things unexpectedly won't work, and maybe other students won't be able to use their machines, or we might deny service to something that we accidentally we didn't mean to in the first place. So something like the man command's a good one to get a hand on, and just how you navigate around man, and if you use the less command to look at output for things like help for tools and things like that. So if you know how to go forward and back and quit out, and just navigate around these things, it's useful going forward. So we're going to look at some basic networking, some basic operating system commands. So you really do need to know how to use the command line as well as the GUIs, You know, -8, -H for help, or -- help. Typically, these sort of flags give you help on commands in Linux, as well as the man page there where we looked at. And in Windows, /? Is pretty much the same thing as -H. So another thing in this class or these types of classes is looking at the comparison between how the implementations on the different operating systems behave. So in this setup with Vyatta, a Linux box, I mean, these are old operating systems, but the idea is, you know, you look at the different ways of doing things in the different operating systems. So we've got a Linux operating system on Ubuntu, we've got a Windows command line OS on our Windows box, and we've also got a Linux type, I think it's Debian based operating system on the Vyatta Firewall. It's just a souped up Linux box really, with some fancy routing and firewalling software added to a stripped down operating system for security. So things like you know, file system commands in Linux and the equivalent in Windows, and whatever equivalent commands are implemented in the firewalls themselves. File content, how to look at files, how to use less or cat, and be able to maneuver around and navigate around in less and get out of it as well, yep, with a queue. And the same sorts of things in Windows, which we might have to go into the GUI, but things like type can do similar things. And then things like filtering content, so the outputs of commands. We want to be able to filter out things with grep, redirect output and input, and a similar command in Windows to grep is find string, so you can pipe things into grep or find string and then look for specific strings and just get the lines that those specific strings are on, which is quite handy when using these types of command line tools. And then we've got networking, so most of the students should have done some networking, but we should be moving away from ifconfig towards IP address, an IP route for Linux, and Windows. We can use the command line, but the GUI is a little bit more straightforward than the command line in Windows. So just for configuring your two hosts at the moment, just temporary IP addressing with IP address or ifconfig, and adding default routes, and in Windows probably just use the GUI for now. And then connectivity testing, so that, you know, the first thing we want to do is test step by step from our local network stack out to our default gateway and then on to the other networks. And we want to be using things like ping and traceroute, which have slightly different implementations in all three boxes that we're using, but that's good to explore and look at the help and see the subtle differences and how they work. And then we've got things like looking at the network services once we've set them up. So if we're using SSH to connect to our firewall, for example, we can use netstat or SS to look at that SSH server and which port it's on and if it's running and if there are any established connections to it. Similarly in Windows, so slightly different syntax, but netstat will give you the servers that are running on the Windows host. And then we've got things like traffic creation, so hping and netcat, crafting different types of traffic, mimicking clients or servers. So netcat's excellent for quickly creating servers and connecting to it, so moving things around the network. And hping's very good for crafting particular types of packets, data, different protocols, mimicking denial of service attacks and such like. So most of you probably have used Wireshark, so it's a kind of traffic display analysis, and it gives you quite a lot of powerful tools for looking at live traffic, but also saving traffic off and analysing traffic later, splitting it up, filtering things out, saving off those particular parts via the filters, looking at stats for traffic captures and specific protocol analysis, rebuilding streams, pulling out files or other things that might be in streams, and it's compatible with many other tools via the PCAP and the new PCAP format. So that's just some basics. I think we've been through most of that stuff already. Using filters, so we'll do that in class. And Nmap is one of these sort of network scanners. So if we want to look at other machines or groups of machines, look for particular services that might be interesting to us, or analyze what machines are running, all the different types of services. We can do all sorts of different scanning. So again, first thing you want to be doing is looking at the help, so -H, probably piped into less, so we can go up and down several pages. We want to be looking at things like host discovery first and then port scanning. So things like finding hosts on the network. Then we might scan them and look at operating system fingerprinting to see what operating systems they're running, and then we might look at individual port scanning, probably without host scanning, so you need to know how to switch these things on and off. We'll probably not get as far as hacking brains. Yeah, this is from Elysium, the film, at the end, where we get a little bit of service version scanning for certain ports on a local IP address, and this is attached to the guy's brain, which is excellent. So in actual fact, yeah, there's a whole section of the Nmap website where you can go and have a look at which films Nmap's been in, quite a lot of famous ones. Yeah, so these are the types of things we want you to be looking at. So instead of just doing Nmap, a target IP address, we want you to be looking at things like SP, which only does host discovery. So you can do host discovery of a group of targets or IP ranges. -N is the other thing you want to be looking at all the time on all of these tools. So don't do DNS, don't do host name resolution, especially if you're not connected to things, because then you're going to get huge timeouts while it goes away and looks for DNS lookups. So you want to use -N for even your routing tables as you're setting up the hosts, much quicker. Even if you are connected to other networks and your DNS and host lookups and things are going to be working, it's still a lot quieter. You can generate a lot less packets. If you use -N, you also get numeric IP addresses rather than resolved names and things like that. So -N doesn't do protocol lookups and DNS resolution and things like that. So typically you're going to want to use -N for most things. That's probably the one port scan to start with. So this is looking for hosts without doing any port scanning. This is port scanning a host, a single host typically, and this is I think this is the default scan. This is a half open scan, which does a connection, and as soon as it gets a connection back from that target port, it'll send a reset. It doesn't actually need to do a full connect, a three-way handshake. It can just reset the connection because it knows the port's open. So this is how Nmap targets ports and checks if they're open or not. So unless you're doing version scanning where it might send some other packets to look at what's running, typically you want to close the connection as quick as possible, so you can get onto the next port and take as little time as possible. And that's just a kind of Wireshark scan, analysing the -S. So you've got the SYN going out and you've got the SYNAT come back from the target. In this particular case, it's FTP. So this is your ephemeral port here from their scanning machine to FTP. FTP's coming back saying, "Yep, I'm open. You can connect to me. We don't need to. We're happy. We've found there's an open FTP port or service. We'll just reset that connection and get on to the next one, which is this one here, sending the next SYN." Okay, so quick look at firewalls. So firewalls typically are segregating two networks. So you've got two networks, and they're going to stop some sort of bad traffic, typically all traffic, and they're going to allow some particular traffic that we might want to allow through between those two networks. So reject bad traffic, typically everything, depending on what type of firewall and where it's situated, and allow some sort of good traffic. So it comes from kind of buildings or cars where you had these fireproof sections or partition walls. And this is quite a good analogy. So the way to think of it is it kind of connects two networks. It kind of brings everything together to a sort of choke point where we can do some processing. We can apply some kind of rules. So it's a little bit like a castle gate or gatekeeper, where everything has to go through that and someone can decide who gets in and who gets out. So it's a little bit more complicated than these ones, where everything's getting stopped. So we're stopping all bad traffic from coming in, because we might want to let some of our good guys out, and then we might want to let them get back in and such like, and we might decide that some of these guys might be allowed to come in too. So this is our Vyatta firewall, which we're using just at the beginning. So it's a kind of command line based firewall, which is quite a good one to play around with and get used to. So when you log into the Vyatta firewall, you get a kind of operational command mode, which is mainly used for viewing things. So to view things, we use the show command. So we can do things like show configuration, show interfaces. If you do show question mark or show tab, you'll get a whole list of the options, all the different things you can look at, which are quite useful. And if we want to change things or configure things, like routing and firewalling, we have to go into configuration mode. So this operational command mode is denoted by a prompt of $, and once we type configure return, we get a hash. So that shows we're in configuration mode, and we can use things like the set command, which aren't available in operational kind of command mode. So we can do things like set systems, we can create our SSH server and things like that. We can set interfaces up, we can set routing up, and we can set I should say services when I'm talking about SSH, and we can set our firewall rules and things like that. Once we've done some changes, we can review the configuration with, again, the show command you can use in configuration mode to look at the configuration you've changed. And once we're happy with that, we can commit things. So when you look at the configurations, you'll see when you make a change, it gets a little plus beside it, so you can see the lines you've changed, you can review them, you can look for typos. Once you're fairly happy, you can commit them, and then you can test them, and you can also save them off as well for next time. So this is a typical kind of setup for a perimeter firewall, and this is the kind of thing we're looking at in the lab. So for each student, we have a kind of inside network with just our one Ubuntu box on, and we've got a DMZ. This one's got several different servers splitting up the services. We've got one server which is running quite a few services, but this shows you the firewalling and the routing between the different networks. So as I said, the firewall is going to do firewalling between two networks. Okay, so whether it's between these two or these two or these two, you're basically going to be putting different firewall rule sets or different firewalls for either the interfaces in a direction or for pairs of networks. So from this network to this network, or from this network to this network, we're going to put some rules on to allow certain traffic through and to block other traffic. So it's quite common from the untrusted kind of internet to block everything, and then just to allow particular traffic through, typically to our DMZ, to get our forward-facing services and return traffic, and probably nothing from outside to the inside network would be quite typical. Whereas from the inside network, we're quite likely to allow most things out and return traffic which is associated with that traffic, to do things like allow users to browse the web and connect to external services. And we might need some traffic between these two for things like configuring our servers and getting access from our inside network to maybe a proxy or email server or such like. So we need to configure our, this is on top of our routing. So a firewall is basically a router with some filtering for traffic between networks layered on top. So once we've got our routing working and we've tested our routing and our communications using things like ping and some services to look at particular services that are working, we can then firewall things and then test those firewall rules. So the way we can do that, there's basically two ways with Vyatta. One, you can create firewall rules and then set them on an interface. So I could create some firewall rules, say from our outside or from our inside, and allow certain traffic through and just apply it to that interface in a particular direction. And then I would have to think about return traffic too. Usually that's used if you've got two networks attached. So say we didn't have a DMZ and we just had these two networks, so this inside and this outside, we might use basic interface firewalling, and we can do things like globally set things, and you can allow all ICMP and things like that, and then you can take off. You can add particular rules to take off particular things, or you can do the other way around, which is more common, which is block everything and then just add accept rules to accept and pass particular traffic that you might want, or particular types of traffic. So you could go right down to particular types of ICMP traffic you could allow through between the two networks. Now we've got 3 or more networks. We might have multiple DMZs, we might have multiple internal networks, but once we get several, what we tend to use is something called zone-based firewalling. So what we do is we define zones or networks, and then we define firewall rules and we apply them across two networks. So this one to this one. So you're going from outside to inside network in that direction, plus return traffic, and maybe inside to DMZ. So that network to this network across the two interfaces in one direction, and this is how you do it. So your zone-based firewalling, you have to set up some kind of zones, so you give them descriptions inside and outside, and then those zones outside is based on interface ETH0. So in this case, outside would be that one there. So that's going to be outside based on the ETH0 interface. So typically your interfaces are on a firewall are ETH0 for outside, ETH1 for inside, and ETH2345 for your various DMZs that you might have. So in this case, we've got ETH0 is going to be called outside, ETH1 is going to be called inside, and we've given them names of private and public. So we could have just called them outside and inside, which might have been easier. And these are firewall rules or rule sets. So in this case, we've only got one rule in each rule set, and this again we've given a description so we can then use those rule sets. And this one is DMZ to private, and this one is in actual fact, yep, that's just a bit of a typo, so that should be private to DMZ, and that one's DMZ to private. And these are setting the rules for these particular rule sets. So in this case, we've just got one rule, and it says action accept. So basically this is saying pass traffic for this rule set, and this is the traffic we want to pass. So traffic destined for either port 80 or 443. So basically web traffic going to a web server, and TCP obviously. So we've got our protocol and our port, which makes up our service, and we've got our action. So this action could be drop. We could have a default allow everything firewall, and we could just drop particular things, but safer to have a closed firewall and only accept the things that we want. So private to DMZ. So in this case we're setting up rules for inside going to the DMZ, okay, just to the web server. So we would typically have a rule from outside as well, and this rule here is basically just allowing return traffic. So again, it's saying accept, which means accept and pass the packets, and it's just established packets which are related to the traffic coming in the opposite direction. So basically that's just setting up return traffic. So that is pretty much just setting up allow traffic to the web server and return traffic. So a little bit like this pair, this green traffic flow pair here, and it should obviously go through the firewall. Oops. So what we do then is, once we've defined our zones and we've defined some rules, at this point we want to apply the rules in a particular direction across two zones. So we take this rule here, private to DMZ, and we apply it from the private to the DMZ. So DMZ from private, it's not the best syntax, and vice versa. Private from DMZ or DMZ to private, we apply that rule. So we're allowing this here, packets to 8TR443 TCP packets. So web traffic, we're allowing private to DMZ, and we're allowing return traffic back. Okay, so once we've done all that, we then review with the show command, and once we're happy there's no typos and it all makes sense and we've fixed that one, we would commit that and then test the firewall rules. So we'd be looking at using web browsers or things like Nmap to test if these ports are accessible in that direction and that everything else is closed down. So VIOS is what Vyatta has become more recently. This is a kind of user guide, so you can go and have a look at that for more commands or any more details on some of these commands here. But when you want to create your own rules, you have to follow the same thing. If we wanted to create rules from say outside to inside, we would just create the same kind of outside to inside, and then create one or more rules allowing certain traffic, and then we would apply them depending on where we wanted that traffic to go. Typically we would, as I said before, we would go to the DMZ rather than going from outside to inside, and then we would just apply them between, so it would be DMZ from outside in that particular case.